do, however, want to go through and look at our periodic table just real quick and just kind of refresh on some of the things we learned last semester. Just a quick refresh just to see what we remember. That way I can see how much we still need to cover in terms of refresh in the next week or so when we do some more review here and there throughout the week. All right, so is there anything you guys remember from the periodic table? Anything you guys remember learning about from last semester? Nothing?
I mean, we learned a bunch of stuff, so you've got to be more specific.
Anything at all. Tell me something that you know about this, about anything on the periodic table. Trends. All right, we learned about trends. What were the trends of the periodic table?
Electronegativity.
Electronegativity, and electronegativity is what? Do you guys remember? It's the tendency for atoms to do something. Exactly, perfect. The tendency or likelihood that atoms are pull on a shared pair of electrons. So electrons, that means it's a covalent bond. So they're sharing electrons, and the pull on that shared pair of electrons causes the electronegativity. The more electronegative means the larger the pull on those shared pair of electrons. Which of these elements is going to have the largest electronegativity? Fluorine, perfect. Fluorine is the most electronegative because it has 7 valence electrons. It's super, super close to having its full octet, which means it's super close to being happy or stable. And it's the smallest one that's super close, which means it's going to have the largest pull on its electrons and the largest pull on a shared pair of electrons. All right, so we know electronegativity. What were some other trends that we remember from last semester? There were 2 more, or 3 more technically. Atomic radius, perfect. What do we know about atomic radius? What happens as we go down the periodic table? Get bigger, get smaller, stays the exact same. As we go down a group. It expands when we go down, perfect. Francium is going to have the largest one, amazing. And that's because of our orbitals. The more orbitals, because we go down each row, we gain an energy level or orbital, which means we are getting larger. Those electrons are getting farther from the nucleus. What about as we go across the periodic table? Are we going to get bigger or are we going to get smaller? We're going to get smaller. Awesome. And we're getting smaller because those electrons, we gain more protons, which means there's a larger Coulombic attraction as we go across, which means those electrons and protons are pulled closer together, making the atom smaller. All right. What's the last one? Trend. Very useful with ionic bonds.
Ionization energy?
Exactly, ionization energy. And what do we remember ionization energy as? Anybody remember?
The amount of energy required to remove ions?
Not ions, electrons.
Electrons.
Perfect. All right. The amount of energy required to remove an electron And so if we're thinking about that, is it going to have small ionization or large ionization energy when we get a larger atom? So as we get to things like francium over here, is that going to have a large ionization energy? Does it require a lot of energy to remove an electron? Or does it have a small ionization energy? Is it easy to remove electrons?
It's easier.
It's easier. It has a small ionization energy. So our ionization energy decreases as our atomic radius increases. So we've talked about those trends. You guys are crushing it with the trends. What else do we know about atoms, about the periodic table, about how it's set up? What else do we know about it? What other information can we pull from the periodic table?
There are 7 periods and 18 groups.
Awesome. 7 periods, which are the rows, 18 groups, those are the columns. Wonderful. Does that help us with anything? Do the periods or group tell us anything besides where they are? Does that give us any information about those elements or atoms?
Tells us like the valence electron.
Tells us the valence electrons. Awesome. So let's figure out those valence electrons. Who can tell me how many valence electrons are in that first column, that first group?
One.
1. Perfect. There's 1 valence electron in that first column, the alkali metals. What about column 2 or group 2?
2.
2. What about group 3?
3.
Group 4?
4.
4. Group 5?
5.
Group 6?
6.
Group 7?
7.
Group 8?
Eight.
Group 9?
9.
Group 10?
1.
Group 11?
Is it 1?
Is it 1 here? Nope. Okay. Group 2?
I don't know.
Well,
When they're double, like for 10, do you subtract 10?
all right. So here's the tricky part. So these ones, I'm going to erase all these. This section right here is called our transition metals. This middle section from 3 to 12. And these ones we can't figure out based off of that. So we just ignore all these. Ignore those numbers. We're going to skip all those when we're counting our valence electrons. Group 13, we're going to come back to with number 3, 4, 5, 6, 7, and 8. So all the transition metals we're skipping over because those ones, where do we have to look to find our number of valence electrons for these elements? Do you guys remember what it's called? Perfect. Our polyatomic ion sheet is where we have to look for these ones because these ones are special in the fact that they don't put their electrons in the outermost shell. Their electrons actually go in the shell beforehand, which means that we have to worry about those ones as special charges. If we think of things like titanium, titanium has 4 different charges that it can have. It can have a charge of a +2, a +3, a +4, or even a +5. Vanadium has like 6 different ones. Cobalt has 2, iron has 2, copper has 2 different ways it can lose electrons. So these ones all in here are special. They do not follow our trend. We can't worry about them in the same way. We wouldn't be able to identify just looking off the periodic table how many valence electrons they're going to gain or lose. So these ones are special. with the amount of valence electrons they're going to have. We have to worry about them from that polyatomic ion sheet. Perfect. Is there any other information we learned last semester that's important to us from the periodic table? What if I look specifically at like carbon right here? What is this number?
The amount of electrons.
Amount of electrons, perfect, in a neutral atom. What else does it tell us?
The protons.
The protons, perfect. So that's our atomic number. It tells us our protons and electrons in a neutral atom. All right, what about this number down here, the 12.011?
Atomic mass.
The atomic mass. And what do we use our atomic mass for?
To find our electrons.
Not to find our electrons, but what do we use it for? If it's not protons and it's not electrons, we use
neutrons.
Use it to find neutrons. Perfect. What else does this number help us with? Part of that last unit we worked on. What else does that number help us with? Who remembers that one?
Solubility.
Solubility. So non-solubility, that was our last unit, which was great. But specifically one part of that last unit, we used that 12.011. We put some units on that one. Do you guys remember what those units were? Does that look familiar? Grams per mole? Do you guys remember that? Or
Yeah.
yeah, so that's the amount of grams that equals 1 mole when we do conversions from grams to moles to help us figure out how much of each thing we have. So that's going to be super important throughout this unit. We're going to be using that, the grams to moles conversion in this unit. We're going to use it a lot in the next unit. So I just wanted you guys to remember these kind of things. Lots of information just comes from that periodic table, and I wanted to just refresh on what information we learned last semester, just to see where you guys were at and all that, which you guys did great, and you guys remember a ton from last semester, which is wonderful. You guys, I don't have too much left for you guys. There's just one more thing you guys have to do, and this can be done on your own. So once we talk about it, you are good to go. And that's just going to be this wonderful law of conservation of mass Edpuzzle, or law of conservation of matter Edpuzzle. It's not too long. It's just got a few questions for you to answer. Once you finish that, please also complete this get to know you quiz, and then you are done.